Greetings and welcome to the Introduction to Astronomy. In this episode of Special Topics in Astronomy, we will talk about tidal forces and how differences in gravity can shape objects throughout the universe. So let's get started. Why does gravity stretch objects? Most people associate tides with oceans on Earth, but tidal forces are not limited to oceans. They can reshape moons, heat planetary interiors, tear apart stars, and even influence the evolution of entire galaxies. The key idea is surprisingly simple. Gravity becomes weaker with distance, and that small difference can have enormous consequences. Imagine an object located near a massive body. The side closest to the massive object experiences a slightly stronger gravitational pull than the far side. Because gravity is not exactly the same across the entire object, the object experiences a stretching force. This difference in gravitational pull is called a tidal force. The larger the object, or the stronger the gravity, the greater the tidal effect can become. Tidal forces influence many objects in our solar system. The moon produces most of Earth's ocean tides, but tidal forces also affect solid bodies. For example, Jupiter's moon Io experiences powerful tidal stretching due to Jupiter's gravity. As Io's shape continually changes, its interior is heated. That heating powers hundreds of active volcanoes, making Io the most volcanically active world in the solar system. Tidal forces can therefore become a source of energy, not just deformation. In some situations, tidal forces become extraordinarily powerful. If an object approaches too close to a massive body, the difference in gravitational pull can exceed the object's own gravity. When that happens, the object may be torn apart. Astronomers refer to the critical distance as the Roche limit. Near black holes, tidal forces can stretch stars into long streams of gas before they are destroyed. These dramatic events are known as tidal disruption events. The same physical principle that raises tides on Earth can also destroy entire stars. Tidal forces help astronomers understand a remarkable variety of phenomena. They explain tides on Earth, they power geological activity on distant moons, they influence planetary rings, and they reveal how extreme gravity operates near black holes. A single concept connects objects ranging from oceans to galaxies. Gravity is often described as an attractive force, but tidal forces remind us that gravity is not always uniform. Small differences in gravitational pull can gradually reshape worlds, generate heat, and sometimes destroy entire stars. By understanding tidal forces, we gain a deeper appreciation for how gravity sculpts the universe on every scale. So that concludes our discussion on tidal forces. We'll be back again next time for another episode of Special Topics in Astronomy. So until then, have a great day, everyone, and I will see you in class.